Hey everyone, let's walk the walk and talk the talk of Java programming. As you guys can see, I've already created a class called exercise underscore 3 underscore 28C, right? That is to say, we're doing exercise 3.28 from this book here. And if you haven't yet get yourself your own PDF, please do so. I'm not gonna talk much about that. So right now, let's jump on to our question. It's on page 138. Here we go. Let me zoom in so that everyone can see. I mean, among all these exercises we have on this chapter entitled Selections, this is one of the most challenging questions, if you ask me. As you can see, we've got 2 stars next to it, those asterisks, as you can see. So it tells you that this problem can be a bit challenging. Okay, so without any waste of time, let me read it through so that everyone can understand what's going on. Okay, it's a geometry problem, so we're working with 2 rectangles. So what we gotta do is to write a program that prompts the user to enter the center XY coordinates, width and height of 2 rectangles and determine whether the second triangle is inside the first or overlaps with the first as shown in figure 3.9. So you gotta test your program to cover all cases. I cannot stress enough the importance of this part over here. You make sure you come up with something that takes care of all possible cases. You see, with this problem here, you really need to keep checking different inputs, right? Try to put different numbers just to make sure that your thing really works, okay? So let's see the sample runs. They are pretty clear to me. I hope everyone can see. So without any waste of time, let me jump on to my IDE. These are the 2 triangles. So here on figure 3.9a, they showed us a case where rectangle 2 is inside the rectangle 1. And here on B, it's a case where the 2 overlaps, right? Okay, so let me go to my IDE. As you guys can see, I've already created a scanner just to minimize the period it will take for me to complete this exercise. Okay, so here's what I'm gonna do. Firstly, I'm gonna declare variables that will hold values for rectangle 1. So I'm simply gonna go R1 for rectangle 1x for x coordinate, right? That's my first variable. My second one will be R1y, my y coordinates for the first rectangle. And then what I'll do is I'll go R1, not in caps of course, R1 width. And then lastly, I'll simply go R1 heights. Once I do that, I'll then prompt the user to enter first rectangles values. System.out.print. Of course, that's not how you spell the word prompt. Why is this thing messing with me now? It's supposed to be as fast as possible. See, I even made a mistake there because of its speed. Okay, So I said what we'll be doing here, we'll simply go enter R1's X, Y coordinates with height. Perhaps I should have, and height. Let me make sure I have enough space. Okay, once I do that, of course I would have to initialize my variables. It's next double R1Y scanner dot next double R1 with it's scanner dot next. Up to this point there's literally nothing to explain. I hope everyone knows what's going on here, and if you don't, I strongly suggest to check out my solutions on chapter 1 and chapter 2, of course. Maybe it will all make sense to you. In fact, definitely it will all make sense to you. Okay, so here's what I will do for the sake of saving time. I'll simply copy this and then paste it right underneath that. And then I'll replace R1 with R2, R1, R2. Because both they have the XY coordinates, the width and the height, right? Instead of 1 there, I'll simply go 2. And then I've got to put second right over there. Of course, this is supposed to be 2 again. All these values. And then lastly, R2 height. Okay. Now that we've collected all the data we need for this exercise, here, this is the part where we work with our logic. Okay, before I even get started, there's something I want to talk about here. You see, with a problem such as this one we're facing, you see, there are different ways of doing it. And right now, I will only give a simple one. However, it won't challenges mentally. It is gonna be simple. However, you won't gain much out of it, which is not the main purpose of this channel here. I want you guys to know different ways of doing things. I want you guys to get challenged as much as possible, right? I want you guys to to gain a lot out of this. So the solution I'm about to give right now won't be as productive as the one I will give later on. By later on, the one I will give from student A's perspective. I know I've been saying that student C is smarter than student A. However, in this case, student A will give us something that will work, that will make that will cause our mind to work, right? Which is the main purpose of this tutorial. You've got to have your mind up and running. Okay, enough with the words. Let's get started. So here's what I will say. I will simply check if, I'll do 3 things before I even write any code. Firstly, I'll check if R1 is within R2. Secondly, I'll then check if that is not the case. I'll then check if there's no intersection at all, right? And then lastly, it's gonna be the case where the 2 rectangles intersect. So or let me just go R1, R2 is within R1. Okay, so here's what I'll say. If R2 x minus, basically this is the left boundary of R2, right? So if the left boundary of R2 is greater than or equals to the left boundary of R1, if that is the case, the left boundary of the R1 with, okay, we're saying if the left boundary of R1 is greater than or equals to the left boundary of R1, or let me rephrase that. If the left boundary of R2 is greater than the left boundary of R1, that's what we're saying. So what I'm going to say in that case, in fact, we're not done. That's a partial condition. Okay, if that is the case and R2 top boundary is less than or equal to R1 top boundary, that's what I'm trying to say. If R2 top boundary if R2 top boundary is, did I say less? Of course, if it is less than or equals to, let me just copy and paste that. If R2 top boundary is less than or equals to R1 top boundary, we're not done there, right? There are other cases too we've got to include. So far we said if R2 left boundary is greater than R1 left boundary and R2 top boundary is less than or equals to R1 top boundary, and what else we want to say? We want to say R2 top boundary is less than or equals to R1 top boundary. Oh, I made a mistake. What I want to say if R2 left boundary is greater than or equals to R1 left boundary and R2 right boundary is less than or equals to R1 right boundary. Or what else I want to say? I want to say and R2 right boundary. Perhaps I should code this and then try to explain it later because I feel like I'm confusing people here. So here's what I want to do. Let me just go. Let me code it and try to explain it later. Let's just go R2 right boundary. R2. Perhaps copying and pasting would simplify things here. Okay. So R2 right boundary is less than or equals to R1 right boundary. Okay, so what I said is R2 left boundary is greater than or equals to R1 left boundary. Now I'm saying R2 and R2 right boundary is less than or equals to R1 right boundary. And then right over here I'm saying R2 top boundary is less than or equals to R1 top boundary. So now I've got to put my last case. I'll simply say R2 bottom boundary is greater than or equals to R1 bottom boundary. Here's what's gonna help me. I'll simply copy and paste that and then say minus over there. So this is nothing else but R2 bottom boundary. We said that is greater than or equals to R1 bottom boundary. So if this case holds, then we can simply go system.out.print R2 is inside R1, right? I hope everyone is clear on this, but I'm gonna try to go. Let me try go through it again. Okay, this over here. That on line 21, the portion I just highlighted, it tells you that it simply says R2x minus R2 width times height. There is nothing else but the left boundary of the second triangle. Right? Okay, we're saying if that is greater than or equals to the left boundary of the first triangle and the right boundary of the second triangle is less than or equals to the right boundary of the first triangle, and the top boundary of the second triangle is less than or equals to the top boundary of this first triangle. Okay, and the bottom boundary of the second triangle is greater than or equals to the bottom boundary of the first triangle. If you can't see that, look at this. You see figure 3.9a holds on this condition here. Okay, so let me continue now. Let me deal with the case where there is no intersection or overlap. Else if, so in that case, again, let me try to type it and then I'll explain it later. What I'll simply do, I'll go R2 X, or perhaps let me just copy and paste this. It's gonna be a bit simpler. Okay, what I'm saying here is the left boundary of R2 is greater than, not greater or equal to, is greater than the right boundary of R1. If this is the case, or basically we're saying if there's a gap between if there's a horizontal gap, right? If there's a gap between vertical boundaries of our rectangle, that's what we're trying to say. If there's a gap between two triangles, more specifically between the left boundary of R1 and the right boundary of R2, or the left boundary of R2 and the right boundary of R1. Okay, maybe I'm confusing you guys, but I'll explain it later on once I'm done with the condition. If this is the case, or R2 or the left boundary of R1, the left boundary of R1 is greater than the right boundary of R2. The right boundary of R2. Okay, if this is the case, this alone tells us there's a gap between our vertical boundaries, the ones that are close to each other, of course. Okay, so now we gotta take care of the case where there are gaps between our horizontal boundaries. Maybe the top rectangle is one boundary and the bottom rectangle two boundary, or vice versa, right? Okay, let me just put that condition. What I would say is RY bottom boundary R1, so I'll simply go, or R1 bottom boundary, or R1 bottom boundary is greater than R2 top boundary. R2 top boundary. Here's R2 top boundary. Right, are we clear so far? I hope so. Okay. Of course, I need to put another case right over here. I'll simply go, or let me just switch this from 1 to 2. And then that from 2 to 1. I hope people see the logic here. So what I'm trying to say here is, this portion, this alone, what it says is, it simply checks if there's a gap between horizontal lines, right? Vertical lines. Of course, I'm talking about vertical adjacent lines on the two triangles, right? That takes care of that, because it simply says if the left boundary of R2 is greater than the right boundary of R1, or the left boundary of R1 is greater than the right boundary of R2. If that is the case, then we do know that we have a horizontal gap. Or if the bottom boundary of R1 is greater than the top boundary of R2, or the bottom boundary of R2 is greater than the top boundary of R1. If that is the case, then we can conclude that system.out.print, you can conclude that there's no intersection, right? R2 does not intersect R1 or overlap. Let me just copy that. R2 does not overlap R1. Okay. Otherwise, we can simply go system.out.print. Otherwise, you can say the two overlap. R2 overlaps R1. Okay, if you don't trust my solution, you can try different numbers. Try to input different numbers and see if it works or not. Again, let me try to go through my conditions. Basically, on this one here, we check if R2 is within R1. So what we say here is if the left boundary of R2 is greater than or equals to the left boundary of R1, and the right boundary of R2 is less than or equals to the right boundary of R1, and the top boundary of R2 is less than or equals to the top boundary of R1. And lastly, the bottom boundary of R2 is greater than or equals to the bottom boundary of R1. If that is the case, then we know that R1 is inside R2. Okay. However, on this case over here, we check in if there's no overlap. So what we do is we say the bottom boundary of we're saying the left boundary of R2 has to be greater than the right boundary of R1, or the left boundary of R1 has to be greater than the right boundary of R2, or the left boundary of the top boundary of R1 is greater than the bottom boundary of R1 is greater than the top boundary of R2, or the bottom boundary of R2 is greater than the top boundary of R1. If that is the case, then we know that R1 does not overlap R2. Otherwise, the two overlap, right? Okay. Of course, we can try different numbers here, but I'm not gonna put too much. I'm not gonna put many numbers. Let's try something like that. Okay, you see what I'll do, folks, is because it's kind of hard to see whether or not I gave you guys a correct solution on this over here, on this question over here. Why? It's better. It would be better if we had a visual solution in a way to display two rectangles and see whether or not our inputs, they really are giving us what we expected. Whether or not our solution is working right. So what I will then do, I'll give this solution from student A's perspective, and that is where we're gonna see a lot going on, because you see, checking whether or not one rectangle is within the other is way too straightforward, and likewise checking whether or not a triangle is not, one triangle does not touch another triangle, it's pretty straightforward too. So what I'll do is I'll give out a solution from student A's perspective, and what I'll do is I'll also have something else that I'll use so that you guys can validate my solution, right, visually, right? When I give out a solution from student A's perspective, there's gonna be something visual so that you guys can properly see what's going on. We're gonna test tons of inputs so that, just in order to check the validity of our solution. That should be it for this tutorial, you guys. Again, please check out my next solution on this exercise. It is way too important. I cannot stress the importance of it, you guys, because we want to check out for this condition. We want to check when our two rectangles overlap. That should be it for this tutorial, you guys. I'm gone. Cheers.